Cubic roots. Chapter 2. What are cubic roots? And do they sound familiar? So I wonder what this means. First we have square roots, then cubic roots. Square and cubic roots, parts 1, 2, and 3. The two learning goals for today are 1. Understand the concept of cubic roots and is able to use a radical sign to represent the cubic root of a number. And 2. Can use radicals to find the cubic roots of certain numbers and understand that the cubic roots are the inverse operations of each other. A chemical plant uses a spherical gas storage tank with a radius of 1 meter to store gas. Now, a new spherical gas storage is to be built. If its volume requires to be 8 times the original volume, how many times larger is the radius of the new tank than the old one? Now, it's a spherical gas storage, so I want you to think about it by yourself, and we'll be uncovering the answer later in the video. Remember, how to calculate a sphere is that the area of a sphere is equal to 4/3 the radius times pi. Radius is cubed. Okay, now we're just going to be pondering with this, but then let's go into the concept and properties of cube roots. To make a cube model with a volume of 27 centimeters cubed, as shown, how long is its side length, and how did you find it? So let's suppose first. Let's suppose that the edge length of the cube is x centimeters. So then x cubed would equal 27. Everything's okay so far. This is asking for a number so that its cube is equal to 27. Well, 3 cubed is equal to 27, so x equals to 3. Therefore, the side length is equal to 3 centimeters. Now, if you haven't memorized your basic cubes up to 20, so 20 times 20, which is 400, and some of the basic, so your squares and your cubes, the basic ones, calculation is going to get harder and harder for you. So I expect you to start doing more problems, getting stronger in these areas, and that's what's going to really help you get a growth in these. So think. First, what number cubed is equal to -8? And if the volume of the cube was 5 centimeters cubed, what is the side length of that cube? Well, the answer to this is -2, because -2 times -2 is equal to 4, but then that times another third -2 would be -8. If the volume of the cube in the question is 5 centimeters, what is the side length of the cube? That would just be the cubic root of 5. Now, this is the concept of the cube root. Generally, the cube of a number is equal to a. So, if the cube of a number is equal to a, then this number is called the cubic root of a, written in this way. Expressing cubic roots. The cubic root of a can be expressed as this. So, it's read as the cubic root of a. So, a here is a radicand. 3 is a root index right here, and 3 cannot be omitted. If you remember back in square roots, it was written as this, okay? X is greater or equal to 0, by the way. And this, this couldn't, you could put it up there, but usually people just omit it like that, and it's just a radical sign right there. But for 3, 4, 5, 6, and so on, the root index has to be shown, all right? It has to be shown. So fill in the blanks according to the meaning of the cube root. So, because 2 cubed is equal to 8, so the cubic root of 8 is 2. And the following goes like this. So 1/2, that would be 1/2 as well. If something's cubed is equal to 0, well, that to something would be 0. If negative 2 cubed is equal to negative 8, so the cubic root of negative 8 is negative 2, because negative 2/3 cubed is equal to 27, negative 8 over 27, so the cubic root of negative 8 over 27 is negative 2 over 3. So here's a key point summary from that practice. The properties of cubic roots are that positive numbers have positive cubic roots. And as I'm saying this, I expect you to be taking notes on this. This is one of the key points that this lesson is going to teach on. Negative numbers have negative cubic roots. Zero has a zero as its own cubic root. So if the cubic root is itself, that would apply to the numbers 1, negative 1, and 0. Square root itself, only 0. So 0 is a very, very special number. Now we're going to learn about some cubic root related operations. So every number has its own cubic root expressed as the cubic root of a, read as cubic root of a. Example, when x cubed is equal to 7, x is the cubic root of 7. So 3 is a root index again, and a is radicand. Notice root index 3 cannot be omitted. This is the second time I'm saying it. So the operation of finding the cubic root is called taking the cubic root, and a is called the radicand. Now I'm just going to give you some problems. We're going to do it together. So find the cubic roots of the following numbers. Okay. Well, we know that the cube root of, so we know that negative 3 cubed is equal to negative 27, so the cubic root of negative 27 is negative 3. So therefore, the cubic root of negative 27 is negative 3. This one. Well, we know that, remember, this is a fraction, but we just have to look at the cubic root of the numerator and denominator. So let's first look at the numerator. We know that the cubic root of 8 is 2, so that's the numerator. And we know that the cubic root of 125 is 5. So then it would be 2 over 5. The same here, also fraction. So first we turn 3 3/8 into a improper fraction, and then we get 3 over 2. For number 4, it's 0.6. If you're really good at calculations, there you go. You can use it with decimals. This is using with decimals. I suggest using it with fractions more because they're easier to look at. But if it's fine for you, sure. And the cubic root of negative 5 is just the cubic root of negative 5. There is no change in that. So, discovery 1. Find the following and fill in the blanks. Okay, this is the cubic root of 2. This is for 0. Negative 2. Negative 3. This is so with any number, this always is true. So cubes and cubic roots are the inverse operations of each other, which means that whenever you see a cubic root outside or inside of a cube, those two operations cancel out and just have a. Okay, there we have it. Discovery 2. Find the following. Okay, same as before, just that it's a different order. Can you do it? Alright, well this is equal to 8, 27, 0, negative 8, and negative 27. So with any number, the cube of a cubic root is just going to be that number that's being cubed in cubic rooted. So that's just a. These two cancel out just as before. Find the following, and these are a few decimals, but you have to be careful where this negative sign goes. Alright, so this is equal to negative 0.2, and this is equal to negative 0.2 as well. So the cubic root of negative a is equal to negative cubic root of a. So to find the cubic root of a negative number, you can first find the cubic root of the absolute value of the negative number and then take its opposite. So opposite would just be opposite number, which means that if you find the cubic root of a negative number, you can first just find, so if you're trying to find the answer to this, first just find the answer of this part and then add the negative sign. So the negative sign can be moved directly from inside the root sign, inside the radical to outside the radical. Now we're going to look at some of the differences and connections between square roots and cubic roots. Looking from properties, if it's positive, positive numbers have two square roots, each as opposites. And if it is a positive number, it only has one cubic root and it's positive. If it's 0, both of these are just 0. 0 is very special, has its own category. It's neither positive nor negative. Negative numbers have no square roots, but they have one negative cubic root. This table is like concluding a lot of the information we've learned so far in this lesson, so I hope you can be paying attention. Now here's how you express square roots. Express it this way. While for cubic roots, you have to make sure not to omit that 3 right there, or else it'll get confused with just a square root. And this is the possibility range for radican. Radican is just a over here. So for cubic roots, a can be any number, while for square roots, it has to be non-negative. Okay, this is something that students often forget, so I hope you can remember that. Let's do some more practice. Find the following. Now, this shouldn't be too hard. We just went over this. So this is equal to 0.5. Yeah, negative 4. Also negative 4, 5, and 16. These cancel out. You just first find this and you get negative. These two are equal. And for this, you can first turn it into a fraction. Okay, let's find the following. Well, for the first, I already gave you the answer. It's negative 2, but I want you to try to do 2, 3, and 4 by yourself. All right, so the cubic root of 0.064, you can just put it this way, actually. If you know that, well, it's actually, there is no need to do this, but you could do this if you know that 0.4 cubed is equal to 0.064. And then cancel those two, you get 0.4. This is really just negative, and then you turn this into 2 over 5 cubed, cancel out, you get negative 2 fifths. And this, just cancel out, you get 9. Class summary. We learned all about cubic roots, its concepts and properties, and related operations to it, like inverse operations. The 2 skills I want you to come out with today is first, understand the concept of cubic roots and is able to use the radical sign to represent the cubic root of a number. Can use radicals to find the cubic roots of certain numbers and understand that cubes and cubic roots are the inverse operations of each other. In this lesson, we learned all about square, arithmetic square root, so square roots, arithmetic square roots, and cubic roots. So not too hard, are they? Not too bad. They are the inverse operations as a conclusion of powers and exponents. And we are going to be doing some estimating in our next lesson. So see you.